Unlocking the Universe, the LHC, the Higgs boson, and the hidden potential at CERN. The Large Hadron Collider, LHC, stands as one of humanity's most ambitious scientific undertakings, a testament to our relentless pursuit of understanding the universe at its most fundamental level. Nestled beneath the Franco-Swiss border, this colossal machine smashes particles together at near-light speeds, offering scientists an unprecedented glimpse into the subatomic world. Among its most celebrated achievements was the 2012 discovery of the Higgs boson, a particle long theorized but never before observed. Often referred to as the God particle for its pivotal role in explaining why matter has mass, the Higgs boson confirmed a cornerstone of the standard model of particle physics. Its detection was not just a triumph of engineering and collaboration, but a milestone that reshaped our understanding of existence itself. Yet, with great discovery often comes deeper mystery. Renowned physicist Professor Brian Cox once issued a statement that has lingered in the minds of scientists and the public alike. He spoke ominously of a hidden potential uncovered at CERN, alluding to findings and phenomena that, while not yet fully understood, could one day redefine physics as we know it. This statement has sparked both excitement and unease within the scientific community. What exactly lies beyond the known? Could there be dimensions we've yet to perceive, forces we've yet to name, or particles beyond the Higgs waiting to be unveiled? CERN researchers have long posited that the LHC may eventually reveal physics beyond the standard model. Already, it has hinted at asymmetries in matter and antimatter, offered insights into the nature of dark matter, and opened questions about the possibility of parallel universes or micro-black holes. While such topics may sound like science fiction, they are rooted in real theoretical frameworks, ones that scientists are now actively testing. The LHC's ongoing upgrades aim to increase its power and sensitivity, potentially pushing it to the threshold where new physics could emerge. However, these advancements are not without controversy. Critics voice concerns about the ethical implications of probing such extreme forces. Though experts maintain that the risks are minuscule, the idea of unintentionally unleashing unknown phenomena naturally provokes public imagination and anxiety. Still, the pursuit continues. The LHC remains a beacon of curiosity and discovery, challenging our perceptions of reality and inviting us to question the very fabric of the cosmos. Whether the hidden potential Professor Cox referred to leads to revolutionary breakthroughs or simply more questions, one truth remains: we are only at the beginning of understanding the universe's deepest secrets. And perhaps, in that unknown, lies the next great leap for humankind. Beyond the event horizon, what the LHC might still reveal. As scientists continue to peer into the fabric of the universe, one thing becomes clear: the more we uncover, the more the cosmos whispers that we've only scratched the surface. The concept of a hidden potential at CERN doesn't just refer to new particles or forces, it suggests a doorway to a deeper understanding of reality itself. What if the laws we've taken for granted are only local rules, small parts of a much grander system of physics? The LHC might not only challenge the standard model, but also challenge our place in the cosmos. Some theorists propose that the collider could eventually help detect evidence for string theory, an idea that posits the fundamental constituents of reality are not particles, but vibrating strings of energy. Others speculate about quantum gravity or even the elusive graviton, a hypothetical particle that could unify general relativity and quantum mechanics into a single, elegant framework. These ideas are not idle dreams. They are built on decades of mathematical predictions, supported by anomalous results, rare decay patterns, and strange energy readings that hint at something more. But science isn't just about the technical breakthroughs. It's about human curiosity, the same spark that made ancient astronomers track the stars or Renaissance thinkers dissect light. The LHC is, in a very real sense, the latest expression of that spark. It is a machine that doesn't just accelerate particles, it accelerates our understanding of ourselves. As we reach further into the unknown, some ask, should we proceed with caution? Perhaps. Yet history has shown us that knowledge, especially hard-won scientific knowledge, rarely leads to destruction when pursued with wisdom, transparency, and shared purpose. What we choose to do with that knowledge defines who we become. In the coming years, with the LHC set to undergo further upgrades as part of the High Luminosity LHC, HLLHC, project, our capacity to explore the quantum frontier will only expand. More data, greater precision, deeper mysteries. The journey ahead is not just a continuation of science, it's the next chapter of a human story that began with firelight and wonder. So, what lies beyond the Higgs boson? Beyond the current limits of physics? Perhaps a new theory of everything. Perhaps a glimpse into the multiverse. Or perhaps, something no one has yet imagined. What is certain is this: the universe still holds secrets. And at CERN, they are listening. Venturing into the unknown, the LHC, dark matter, and the ethics of discovery. The Large Hadron Collider, LHC, buried deep beneath the border of Switzerland and France, is often celebrated as a monumental achievement in physics and engineering. But beyond its technological marvel lies a profound truth: it is not just a machine, it is a gateway. A gateway to realms of the universe that, until now, have been locked away in the fabric of spacetime. While the LHC is designed to uncover the very building blocks of existence, its mission goes far deeper than particle collisions. It represents a bold step in humanity's journey to understand what lies beyond the visible, what forms the dark tapestry that holds the cosmos together. Chief among these mysteries is dark matter, an invisible substance that, though undetectable by traditional means, is believed to make up roughly 85% of the universe's total mass. At the heart of LHC experiments are high-energy collisions that recreate the extreme conditions of the early universe. In these brief but powerful interactions, scientists observe the birth and decay of exotic particles. Among them, they hope to detect signs, however faint, of dark matter or other unknown phenomena. If such a breakthrough occurs, it could completely reshape our understanding of reality. It may confirm the existence of particles that interact only through gravity or through forces beyond the standard model, and could even unveil hidden dimensions curled into the structure of spacetime itself. But with this immense potential comes an equally immense responsibility. The LHC serves as a sobering reminder that progress is rarely free of ethical implications. As we push deeper into the unknown, we must ask difficult questions. Are we prepared for what we might find? What consequences, intended or otherwise, might arise from unlocking secrets we barely understand? And most importantly, who bears the responsibility for guiding these discoveries with wisdom? These aren't just philosophical musings. History has shown that the tools of discovery can also become tools of destruction when wielded without foresight. The atomic age began with a breakthrough in physics, but it also ushered in an era of existential threat. The lessons of the past must walk beside us into the future. Yet, there is also hope, because the pursuit of knowledge, when guided by ethical awareness, can elevate humanity. It can unite nations in curiosity, inspire generations of thinkers, and drive innovation in ways we cannot yet imagine. The LHC embodies this duality. It is both a scientific probe and a mirror, reflecting back our deepest values and intentions. As scientists continue their relentless search for dark matter and other cosmic truths, the world watches with awe, anticipation, and a hint of fear. Because in discovering the nature of the universe, we are also discovering something about ourselves, our courage, our limits, and our place in the grand design. One thing is certain: the journey into the unknown is far from over. But with every step, we light a candle in the dark, and little by little, the cosmos begins to answer back. The next frontier, humanity's role in a post-discovery era. As we inch closer to unlocking the secrets of dark matter and perhaps even glimpsing into hidden dimensions, a new era of responsibility begins to dawn. The discoveries that may emerge from the LHC are not just theoretical curiosities, they could redefine technology, energy, space travel, and even consciousness itself. Imagine a future where understanding dark matter leads to breakthroughs in energy sources that are clean, infinite, and non-destructive. A world where transportation isn't bound by roads and fuel, but by the manipulation of spacetime. It sounds like science fiction, but so did gravity waves, black holes, and quantum entanglement once upon a time. With each scientific leap forward, humanity moves one step closer to reshaping the very world we live in. But the question remains: will we be wise enough to wield this knowledge with foresight and unity? Global collaboration, transparency in research, and public engagement are essential pillars in navigating this delicate path. The LHC is operated not by one nation, but by a coalition of brilliant minds from around the world. It is a model of what is possible when borders dissolve in the name of discovery. Still, we must remain vigilant. With the power to understand the foundations of reality comes the temptation to exploit it. Scientific discovery must never become a tool of division, domination, or destruction. It must remain a bridge, between nations, between generations, and between the known and the unknown. The Large Hadron Collider is not the end. It is the beginning. It invites us to dream bigger, question deeper, and explore further than we ever have before. As it continues to operate, and as newer, more powerful colliders are proposed for the future, we stand at the threshold of a profound transformation, not just in our scientific understanding, but in the way we see ourselves. In the silence between particle collisions, in the brief flashes of subatomic chaos, a greater message echoes. There is still so much to learn. There is still so much to become. And the universe is waiting.